Okay, today's video is graphing systems of inequalities. Alright, so the first example, here is your two systems. So there is your first inequality. So this reads y is less than x plus 5. Y is greater than or equal to negative 2x plus 1. Okay, in grade 10 you learned y equals mx plus b was slope-intercept, where b was your y-intercept and m is your slope, which would be your rise over run. Okay, so 1, 2, 3, 4, 5 is my y-intercept, where I start. Then what is the coefficient of the x? A 1. So really the slope is 1 over 1. So I'm going to go up 1 over 1. Okay, now you can see my line is going to be like this, but before you draw a line, you have to say, am I equal to this line or not? So this says just less than this line, so you're not equal to it, so you draw a dashed line. Okay, then you can see that angling up here would be greater than it, and angling down would be less than it. So we want to be on this side. Okay, number 2 has a y-intercept of 1. Then it tells me to go down 2, right 1. Down 2, right 1. Now it also tells me that I can be equal to this line, because greater than or equal to. So now I can draw a solid line. Greater than would be angling up. So the solutions would be anything in this region greater than this line, but less than that line. Also, a solution would be here, 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 not here. Okay, so how can you check? Am I correct with where I shaded? Well, pick a point where you shaded. So here could be the point 10, 0, x, y. Plug that in to each one. So I'm plugging in, so this would be 0 is less than 10 plus 5. Is 0 less than 15? Yes. If I plug it into the second inequality, is 0 greater than or equal to negative 2 times 10 plus 1? Is 0 greater than negative 19? Yes. So this point is a solution, and it is included in our shaded solutions. Okay, example 2. I'm going to give you 3 inequalities. X is greater than or equal to negative 5. Negative 2x plus 3y minus 9 is greater than 0. Negative 4x minus 2y plus 6 is less than or equal to 0. Okay, so I'm going to graph it down here. X is greater than or equal to negative 5. It doesn't have an x and a y, so it's a special line. So is it a vertical or horizontal? So this would be x being negative 5 is over here. So anywhere in this up and down line, so a vertical line. So I am greater than or equal to, so it's a solid line. Greater than would go this way. Those x values on this side are greater. Okay, 2 and 3 are given to you in general form. Remember this last year? And you had a little formula to find slope, which was negative a over b. And y-intercept formula was negative c over b. So let's do that. So equation number 2, we're going to do negative a, which is positive 2 over b, which is 3. And then the y-intercept would be the opposite of this, so positive 9 over 3, which is also 3. So up at 3, and my slope goes up to right 3. So now I draw a dashed line, because this is greater than, but not equal to. So I'm just going to put a little 2 at the end of that, a little 1 at the end of that, so you know which line that is. That's a 2. So now this angling up, this would be angling down, and we want to be greater than, so we want to be on this side of that line. Okay, now equation 3, I'm going to take negative a, so that's a positive 4 over negative 2, which is a negative 2 slope, and then opposite of 6 divided by negative 2, which is a positive 3. Okay, so there's my positive 3. It's the same intercept, but this time it's a down 2, right 1. Down 2, right 1. This says I can be equal to the line, so it's solid. Okay, now here's the funny thing. It's a rule. If you divide by a negative number, your inequality flips. So instead of thinking my line has to be less than or equal to it, it makes it flip to greater than or equal to. So now I'm angling, looking at the angle going up, which is that. And so my shaded solution would be any solution in this region. And again, you can check a point. So it looks like the point 0, 10 would be in our solutions, right? So let's go into equation 1. So is 0 greater than or equal to negative 5? Yes. Negative 2 times 0 is 0, plus 3 times 10 is 30, minus 9. Does that work? Yes, that's 21 is greater than 0. And then negative 4 times 0 is 0. Negative 2 times 10 is negative 20. Plus 6, is that less than or equal to 0? Yes, because that's a negative 14. So this point works for them all, so we did shade in the right area. Okay? Solid lines for equal to, dashed for not equal to, and please remember this rule when you're doing your algebraic work. If you have to divide by a negative, it flips.